Okay, we're looking at exercises 8.1. So, yeah, um, 8.1. So here's number one, and the number of distinct variants is just one, because we could do x1 plus x2, or we could do x2 plus x1. And those are different variants, however, they're not distinct. So this is basically the same thing as that. Yeah. Okay. All right, next one. So now we're looking at x1 minus x2. In this case, we can get two distinct variants because x1 minus x2 is different than x2 minus x1. In fact, let's say we had 1 minus 3, that's going to be negative 2. And if we have 3 minus 1, that's going to be positive 2. So we have positive and negative of the same number, which in this one right here is number 2. So we have the same, we have two different distinct variants. Okay, so the same thing here, number 3. We have two distinct variants if we just look at the inside here. But if we just look at the inside here, but then when we square it, we end up with just one distinct variant, because we just negative squared is just going to be a positive number. So it's going to be just one distinct variant on this one. Okay, so number 4 here, we could do x1 divided by x2, or we could do x2 divided by x1, and we get two distinct variants here, because it matters if the numerator and the denominator. All right, next one. So we are now looking at number 5, I believe. Yeah, number 5. So in this case, there's only one distinct variant, because x1 divided by x2 plus x2 divided by x1, well, that's the distinct variant. But if we switch the x1s and the x2s, then we get x2 over x1 plus x1 over x2. And notice that here's x2 over x1, x2 over x1. And then here, we can get x1 over x2, x1 over x2. So if we had like a negative here, then I believe that we could have a two distinct variants. However, that's a positive number, so I think it's only going to be one distinct variant. All right, so one distinct variant for number 5. Keep going. And we're now looking at number 6. Okay, so I'm going to put 1. Oh, 2. 2. This one is 1, 2, and 1. All right, number 6, sine of x minus y. So x minus y, remember that we can get a positive and negative doing x minus y or y minus x. So really what we're looking at is positive and negative angle. So if we're looking here at this negative, let's say, angle, and this positive angle, this right here is going to be sine this value. So, or this value is going to be the sine of the angle. So we could get a positive and negative as well. So this is going to be, so the sine of a positive, well, let's just say we could get two distinct variants. Yeah. 2. So cosine of x minus y, I believe this is different. So number 7, this is going to be, let's say cosine of x minus y. We know we can get a positive and negative because, for example, 3 minus 1 equals 2, but 1 minus 3 is negative 2. 1 minus 3 is negative 2. So we're looking at the x minus y and the y minus x here. So we're looking at positive, negative. So if we're looking at of the angle, so if we're again looking at this positive and negative of that, we're cosine gives us the x value. So either case, we're gonna get, if we're looking at the cosine of this angle, we're going to get this value. But if we have the cosine of this angle, again, we're gonna get this value, right? Okay, so in that case, it is one distinct variant. Okay, so now we're looking at number 8, and in this case, I think we can see that we're gonna get 2 distinct variants. All right, number 9. So I think in this case, we can see that we can get 2 distinct variants because we can do an x1, x2 squared, and an x2, x1 squared. And those are distinct variants. Those are different. Number 10. In this case, I believe we get 1 distinct variant because it doesn't matter if we do x1 cubed, x2 cubed, x3 cubed, or we do x2 cubed, x3 cubed, x1 cubed. We can move those around so they look exactly the same. So 1 distinct variant there. Oh, no. Messed up. Okay, so now we're looking at number 11. So in this case, we could do x1, x2, x3 squared, x1, x3, x2 squared, x2, x3, x1 squared. And so here we can get 3 different distinct variants. All right, keep going. So we're now looking at number 12. And in this case, we can get a few different variants. So we can get x1 plus x2. And notice that this is kind of blocked in here. It doesn't matter how we add x1 plus x2 or x2 plus x1. If there was a minus sign there, maybe it would matter. But okay, so we get a x minus x3 squared. So we can see that's a distinct variant. So what if we switched around the x2 and the x1? Well, that wouldn't matter. Okay, so if we switch these around, it wouldn't matter, right? So let's put a different value here. Okay, that would matter, right? So x2 plus x3 minus x1, now that matters. So then let's also do x 1 and 3 now. 1 plus x3 minus x2, and yeah, that matters too. So inside here is going to be different. This is going to be different, and this is going to be different. Now, I can't think of a way to make the inside of the square any different other than those combinations or those permutations. So then when we square it, that does not collapse anything because these are going to be these could be 3 different numbers. So when you square it, if these were positive and negatives, like for example, if we had an x minus y squared, the inside would have 2 distinct variants, positive and negative, but when we square it, it would collapse those variants. So we would only have 1. But in this case, I don't think that happens, so what we end up with 3 distinct variants. Okay, keep going. 13. Okay, number 13. In this case, we only have one distinct variant. Yeah, one. So if we do what's given to us in the problem, x1 plus x2, and then we switch around, I don't know, 1 and 2. X2 plus x1. And then we do, so this would be x2 plus x3 and x1 plus x3. Did I do that right? Anytime that there's a 1, I get a 2, 1, 2. Anytime there's a 2, I get a 1, 2, I get a 1, and 3's stay the same. Okay, we can see here we get the same thing, because when you look at this value, 1 plus 2, this is the same as this one, 2 plus 1. And then here, we are looking here, 1 plus 3, x1 plus x3, that's the same as x1 plus x3 there. So it's kind of switched around a little bit, but it's the same thing. And then here, x2 plus x3, x2 plus x3, it's the same thing. So if you can try it, no matter how you want to try it, you'll see that it's equivalent to the original. So these are equivalent, and you can't, break out of it. You won't be able to. So one distinct variant for that one. One distinct variant. So now let's look at number 14. So number 14, I believe we can. So let's just experiment with it and see what happens. x1 minus x2. x1 minus x3. x2 minus x3. Did I do that right? 1, 2, 1, 3, 2, 3. Okay, great. And we're going to switch around the 1s and the 2s, just like we did last time. So x2 minus x1. x2 minus x3. And finally, x1 minus x3. All right, so this right here, x1 minus x2, that is going to be a positive version of this. So I'm just going to kind of, well, if this is positive, then this is negative, right? Okay, so those are different, kind of, like not super, super different. Maybe it could still collapse. And then here we get a x1 minus x3. And that is right here. So those are equal. And then here we can get a x2 minus x3, and those are equal too. So we have two distinct variants, but due to positive and negative. Okay, so then if we try it again, let's switch around. 1 goes to 2, 2 goes to 3, and 3 goes to 1. So x1 is going to be x2. So then I'm looking here. x1 is going to be 2. I'm adding 1 on each one. So minus x3. So here 2 goes to 3. Okay. And then x2. So that's going to be x2. x1 goes to x3. x3 goes to x1. And then x2 goes to x3. And x3 goes to x1. Okay, so now what we're looking at here is we're going to compare it to the first one again. So, okay. So x1 minus x2. x1 minus x2. So it's similar to this one, x2 minus x1, but you're going to get, let's say this is a positive and negative. It's a negative positive difference. And then here, x1 minus x3, and here you get an x3 minus x1, so another positive negative difference. So again, if this is positive, then that's going to be a negative. And then here we get a, let's say that x2 minus x1, x2 minus x3, x2 minus x3, those are literally the same. So we can see that this is actually the same as this because these two negatives cancel. Okay, so in this case, we've only been able to find two distinct variants due to positive and negative. So if we squared this whole thing, then we would end up with only one distinct variant because it's due to positive and negative only. So I'm going to go ahead and put here two distinct variants. All right, number 15. Okay, all right, so number 15, you can put, if we're just kind of looking at this one right here, you can put three different values in there, 1, 2, and 3. And so we end up with three distinct variants. All right, number 17. I believe in the back of the book it says 6, but the answer is actually, the answer is actually 3. Because if we're looking at this one right here, we can see that we can put two different ones inside there. Three different ones. All right, now let's look at this. Let's see if we could somehow make number 17 by changing the problem a little bit. Let's say if we had x1, x2, x3, and then it was squared and it was to the third power. In that case, we'd be looking at permutations. So we do x1, x2. Well, okay, so I'm just gonna leave it like that. All right, so then we would get x1, 2, 3, just how we had it. We could do an x2, x1, x3 squared, cubed. So that's different. We could put, we could do 1, 2, 3, 2, 1, 3. Actually, I think I'm gonna do this just a little bit differently. Okay, this is what I'm gonna do. I'm gonna put the x1 there, then I'm gonna do 3, 2. Okay, so then I'm gonna put the x2 here, and then I'm gonna do 1, 3. Then I'm gonna keep the x2 there, and then do 3, 1. And these are different. These are different. And then finally, you can guess what I'm gonna do. I'm gonna put the x3 here at the beginning, and then I'm gonna do 1, 2, and then I'm gonna do an x2, x1. And we can see that these are different too. Let me look at it real quick. I was writing kind of fast here, so 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1. Yep. 3, 1, 2, 3, 2, 1. Yeah, these are looking good. So then I can get 6. So maybe that's what the book was wanting. Maybe there was a typo here. Maybe it wants a 3 there, because then we could get 6. But in the way that it is right now, we would have 3. So then that leads to the next problem, number 19. So in this case, we can see that we can get 4, actually no, we could get 4 distinct variants here. Okay. 18. Just looking in the book real quick. Yeah, and the back of the book agrees with me with number 19 as well. So let's move on to number 21. So number 21 is similar to the very beginning of the book, page 155. In page 155, it'll say that you can get 3 distinct variants if this was a positive here. If this was a positive. But we know that when we get a negative in there, we can get possibly more. So let's look at all those distinct variants. I believe we'll end up with 6 because I think it's double 3. We'll see. Okay, so x1, x2 minus x3, x4. And then we're just going to do a switch this around. So x3, x4 here minus x1, x2. So now we get a positive negative style distinct variant, right? So it's again x minus y equals, so if that's a positive, then y minus x is going to be a negative. So, all right, so then we can also do x1, x3 minus x2, x4. And then similarly, we can do the x2, x4 minus x1, x3. And then we can do this one more round. So then we can pair up 1 and 2, 1 and 4. Yeah, 1 and 4. x1, x4 minus x2, x3. And then also the negative version, x2, x3 minus x1, x4. So those are the distinct variants. And if we squared this whole thing, then that would collapse a lot of these. And if we squared that, then we would end up with half as many at 3 again. So let's look now at what number is this? This is gonna be 23, number 23. So the distinct variance here, I believe, is 3? I think 3. Let's check it out. Okay, so .1.23. Yeah, the back of the book says 6. So we'll see. Okay, so we could do x1 plus x2 over x3, x4. All right, let's move something to the top. So we could do an x1 plus x3 divided by x2, x4. Those are different. Let's move something different to the top. We can do a x1 plus x4 all divided by what's left, x3 or x2, x3. Okay, so now I'm seeing that we can get more than 3. So up at the top now, let's put an x2. Oh no, yeah. Okay, so we already did one of the x2s. Let's put something else on the top with the x2. So x2 plus x3. So we did 1 and 2, 1 and 3, 1 and 4, 2 and 3, and then whatever's left on bottom. So that's going to be x1, x4, Let's put something different with the x2. x2 plus x4. And then x1, x3. And then that's everything different we can pair with the x2. So now let's pair things with the x3. And so we could do, we've already done x3 and x1. So let's pair x1, x2 and x3 and x2. But hey, we already have those paired together. So I think we're left with only one more, which is x3 plus x4. So those are kind of matched together now. So then we end up with an x1, x2 on bottom. And I believe in this case we'll have 6 distinct variants. Yeah. So at first I was thinking 3, but actually it's gonna be 6. So this one. This is 6, and this is 6. And now let's look at number 25. So 21. I'm just checking these, see if they got the right. Okay, yes. Yes. Okay, I agree with most of these. The only thing I don't agree with in the back of the book is 8.1.17. And number 25, yeah, it says 24. I totally agree with that, because it's going to be the whole permutations thing that we learned when we talked about how to change. Oh, hold on, let me erase this real quick. Okay, so we talked about number 17 and how we can get 6 if we changed this. Like, for example, if we change this to a 3, we could get 6 distinct variants. And we were talking about permutations and stuff like that. So that would end up being, for number 17, order totally matters in that case. So we would end up with 3 factorial, which is 6, if that was a 3. So the same thing happens here. Those order matters every single time here, and it's pretty simple, pretty straightforward. So it's actually 4 factorial, which is going to be 4 times 3 times 2 times 1, which is, look at that, it's going to be 12 times 2, this is 24. I agree with the back of the book, it's 24 for this one. All right.